My name is Fahad Alisha and I am a student of Iqra University. My ID is 43484. My ID is 43484. My name is Fahad Alisha and I am a student of Iqra University. My ID is 43484. Here is Inter-Operating System I/O hardware application inter-operating interface kernel I/O system subsystem transforming inter-operating request to hardware operation, and then we learn performance. Next one is I/O hardware inter-operating hardware. Incredible variety of inter-operating devices, common concepts, port, bus and controller. What is a port and what is a bus and what is a controller? Bus, deceased and AC chain or shared direct access. Controller host adapter, you can see here is a controller host adapter. And next one is inter-operating instruction control devices. Devices have addresses used by direct inter-operating instruction, memory mapped and inter-operating polling. The polling system is determine state of devices, command, ready, busy, error and busy wait cycle to wait for inter-operating from devices. Whenever we interrupt CPU interrupt request line trained by inter-operating device, interrupt handler receives interrupt maskable to ignore or delay some interrupt vector to dispatch interrupt to correct handler based on priority. Some unmaskable interrupt mechanism also used for exception. If you can see in the screen, there is a table you can read and learn. Next one is interrupt drive inter-operating cycle. This cycle is determined CPU device driver initiatives inter-operating. CPU executing check for interrupt between instruction, and then CPU receiving interrupt transfer controller to interrupt handler. And then we can the first one is device driver initiative to connect initiative inter-operating, and then input ready output complete or error, generate interrupt signal, and then CPU receiving interrupt transfer controller to interrupt handler. Number 5, interrupt handler process data and return from interrupt. CPU resume processing of interrupting task. And then we can direct memory access. The direct memory access is used to avoid program inter-operating for large data movement, require DMA controller bypass CPU to transfer data directly between inter-operating device and memory. Then we have 6-step process to perform DMA transfer. Number 1 is device driver is told to transfer this data to buffer at address X. Then device driver tell disk control to transfer C bytes from disk to buffer at address X. Then this step will continuous disk control initiative DMA transfer disk control send each byte to DMA controller. Then DMA controller transfer bytes to buffer X, increasing memory address and decreasing C unit C is equal to 0. When C is equal to 0, DMA interrupts CPU to signal transfer computation. That is a period of a cycle which can 6 steps process to perform DMA transfer. The next one is block and character devices. Block devices include disk drives, command include read, write, seek, raw, inter-operating or file system ACs. Memory map file ACs possible. Character devices including keyboard, mic, serial port. Command include get, put, libraries and layer on top allow line editing. Whenever you can look at your screen, block and character devices, and then the block devices include disk driver, command include read, write, seek. And then we have clocks and timers. The clocks and timer provide current time elapsed time timer, which can if programmable interval time used for timing periodic interrupt, iClock, and annex cover and odd aspects of interoperating such as clocks and timers. The next one is blocking and non-blocking interoperating. Input and output, sorry. The blocking process suspending until input output completed, easy to use and understand, insufficient for some needs. Non-blocking I/O call return as much as available user interface, data copy, buffered I/O. Implement VIA multiple threading, return quickly with count of bytes read or written. Process run while input output executes. Difficult to use input output system signal process when input output completed. Next one is a kernel input output subsystem. Scheduling some input output requests, ordering via per device request, some OS try fairness. Buffering store data in memory while transferring between devices. To cope with devices speed mismatch, to cope with devices transfer size mismatch, to maintain copy semantics. And then we have a kernel input output subsystem. Catching fast memory, holding copy of data, always just a copy key to perform spoiling hold output for a device. If device can serve only one request at a time, for example printing, device reserving provide executive exclusive access to a device system call for allocation and deallocation. Watch out for deadlock. The error handling. OS can recover from disk read device unavailable transist write failure. Most return in an error number or code when input output request fails, system error logs, whole problem reports. Then input output request to hardware or hardware operation. Consider reading a file from a disk for a process, determine device holding file. Translate name to device representative, physically read data from disk into buffer, make data available to requesting process, return control to process. The next one is a life cycle of an input output request. This is a cycle of input output request. You can see in your screen there is a lot of combination in the process. Request input output system call can already satisfy request, and this is a very easy process if you can read and learn. And the time process is input output complete generate interrupt. Next one is performance. Input output, a major factor in system performance, demands CPU to execute device driver kernel input output code. Context switch due to interrupt data copying network traffic, especially stressful. And this is our topic of input output devices. And the input output device is a very far common system, input output system, and hardware and application and kernel subsystem transferring and performance. I hope we learn very well, and this is our topic. My name is Fahad Ali Shah and my ID is 43484. Thank you, and so the performance we can see major factor. Major factor in system performance, demand CPU to execute device driver kernel input output context switch due to interrupt data copy.